Hi, everyone, and welcome to today's webinar organized by JetBrains. I'm Paul Everett, PyCharm Developer Advocate. I'll be your host. My guests are already waving. The topic for today's webinar is PyCharm and AWS Toolkit. It's an interesting format today. We will review a tutorial in the PyCharm guide written by Mukul about AWS with the AWS PyCharm plugin from the AWS team. Acting as our distinguished eminence for all things AWS and beyond, friend of the webinar, Calvin Hendryx-Parker. Welcome, Calvin.
Hello, everybody. I'm so excited to be here. Mukul's done a ton of work on this thing, and I'm really excited to show off all the kind of cool stuff. I learned a ton doing the tutorial myself, so it was a success.
I should mention in the chat, I believe Mukul will be showing up to correct all the mistakes Calvin makes. No pressure, Calvin.
None taken.
But wait, you say, there are clearly two other faces on the screen. Indeed, we have the best, not just the friend of the webinar, the best friend of the webinar, frequent guest, also AWS fan and eminence, Michael Kennedy from Talk Python. Welcome, Michael.
Hello. Thank you all for having me. Calvin, good to see you. Paul, great to see you. I feel like we're hanging out on streams so often these days. It's great.
We, in the last 2 weeks, have done crossover. You had Calvin on, you had me and Barry on for Python 1994. Is it correct to describe you as an AWS fan?
We, over at Talk Python, we do a lot of stuff with AWS. It's not solely what we do for server hosting and whatnot, but yeah, I'll talk about it a little bit later.
We've
got a lot of stuff. A lot of the peripheral services that are really interesting to bring in that are super unique. So that'll be fun.
All right, that will be fun. So here's the format. Mukul put in a crazy amount of work on this tutorial series, video, text, code. He's also in the chat with us, as I mentioned. Make sure you say hi and thank you to him. Calvin will give kind of an overall review of the tutorial, maybe some live coding stuff, bringing his AWS experience in to the key parts that he found interesting. We're also experimenting with our webinar format. We're going to have two intermissions where Calvin and Michael do some commentary on the AWS stuff that was just shown. Plus, each will have a special topic to have a little fun with. If you like this lineup, we're doing a quiz bowl at next week's Python Web Conference. I think Calvin will touch on the conference itself, but the three of us are getting back together again next week to bring a little bit of fun to lunch at the conference. We'll try and sneak a little promotion in later. Okay, with that set up, let's have some fun. Go over to the slides.
I've got questions.
Okay,
so many questions, Paul.
Yes, and you know my joke that I'm about to do. We'd like to make this webinar as live and conversational as possible. So if you have any questions during the webinar, go ahead and ask them in chat. We have some of the PyCharm team and Mukul that will be answering them, but I'll also bring some for the intermission. But don't wait until the end. Go ahead and ask them. We'll have a few pauses where we'll do some of the talking with Calvin to answer the questions. Don't wait for the end. Ask them, what's the number one question everyone always asks? It is this one. Is this thing being recorded? The answer is yes, it's being recorded. Don't ask the question. It's being recorded. We will publish the recording basically immediately because this is now YouTube, and then we will announce it later in Twitter and on our blog. All right, now that we're all set, let's begin. Calvin, give us a tour of Mukul's PyCharm and AWS Toolkit tutorial.
Okay, that sounds great. The URL, you can kind of see it up here under JetBrains/PyCharm guide tutorials intro AWS is super thorough. It really goes over a really good example of using that AWS toolkit with PyCharm. I've been using PyCharm now for quite a few years, and it's actually really integrated into my workflow. But I had not yet taken advantage of the AWS toolkit pieces, and actually I'm pretty excited to show that off because, like many of you, I was very new to it, so it's always exciting to learn new things. So I'm a lifelong learner, and I love doing this stuff. So this tutorial specifically walks you through going through and building a serverless application using Lambda. And using the serverless application model, the SAM toolkit. So I'll show a couple bits on how to get that installed because it's not exactly straightforward. There's some bits you got to do on your own. And then we go into, I'll show the project structure. We'll jump right in and talk about this. It's using MongoDB's Atlas for a data store on the backside. And I kind of understand why right now, because the support for things like DocumentDB and DynamoDB inside of the AWS Toolkit aren't there as rich as like the data grip support for MongoDB. So actually we get to show off a little bit of data grip. It's super easy to actually like connect to the MongoDB instance from my home and then actually see the data going in and out. I was surprised at how quick it is, although I do have gigabit Ethernet internet service, so that helps with making me feel like I'm right next to my database, even though it's running up in the cloud. So I will try not to show off too much because of my fast internet connection here. Let's just jump in over real quick. There's a couple things you're going to need to get started with this tutorial. Well, one of those is going to be to have the SAM CLI executable installed and the AWS CLI. If you're on Windows or if you're on Mac or Linux, Homebrew is a great way to actually get the AWS CLI installed. There's some confusion out there, and that's why I brought it up, because there is a CLI version 1. And so if you pip install AWS CLI like I used to, I'm a big fan of pipx for installing and using those kinds of tools, you will get the CLI version 1. If you want the CLI version 2, the instructions tell you to download a tarball and do a bunch of like loop-de-loops, and I'm not a fan of that for new people because it adds kind of extra noise to the process of the learning. But you can use Homebrew. You just brew install the AWS CLI, and that will get you the AWS CLI in your path, and everything is hooked up and ready to go. It'll also be the latest version of the AWS CLI. There is not a packaging of the AWS SAM CLI in Homebrew. Sorry, on Windows, I assume you can use Chocolatey. I recommend that as a package manager for folks. I did not go check to see if Chocolatey actually includes the AWS CLI, but I imagine it does. If not, the directions on the AWS homepage for CLI gives you instructions on how to download and install the CLI for Windows. For the SAM,
they stopped publishing the CLI to PyPI, right? That's why if you pip install it, you get the old one.
You get the old one. Well, there's a V2 branch in GitHub, and so I don't know all the history behind this, but the new V2 has a bunch of improvements. I mean, it's really worth having, and I don't know why they keep publishing only the V1. So,
Michael, is your theory that this is a permanent thing?
I feel like I remember them having a conversation to the fact that basically we don't want you to have Python set up in order to install the CLI. Except
they want you to download and like run a bunch of junk. That one still doesn't make sense to me. Homebrew is your friend. You leverage that as a developer. Homebrew is a great tool for those of you who want to get like things just installed and running so I can get going. Yeah. Same thing. Well, I installed Docker. You do need Docker for this project as well. I installed Docker from the instructions off of the docker.com website from their documentation, because that'll get you the latest version of the Docker engine. There's also many confusing stories around how to get Docker installed. For Mac and Windows, it's easy. You just download the installable for the Docker desktop. It keeps it.
We also have a comment in the channel about installation for Linux.
So for installation for Linux, you will need to. I added the repository for Docker and then installed from Docker's official repositories to get Docker engine installed, which is why it's confusing on Linux, because there are a couple ways you can go about it, and the names have changed, and there's some like backward compatible like names in the package managers. It's not fun. Go follow the official docs. It's cut and paste, and you'll have Docker running on Linux in no time. And actually on Linux, you'll have the best experience because you're not running an extra VM to run your Lambda code in there. It's actually running as real processes just right on top of your Ubuntu. I'm running Ubuntu here in this case. So back to SAM. To get SAM installed, you do need to download the zip file. You will need to extract it. The instructions inside the tutorial recommended using sudo to install it, and I'm not a fan of that. I try to kind of do least privilege from a security standpoint, but the SAM installer does give you this option for installer and bender. And so if you're on Linux, if I type which SAM, you'll see that I've installed mine into .local bin SAM. So I use that .local bin as my bender. My installer, I just installed it into .local. So for people who want to keep things in their own home dir and have it owned by their user and kind of keep things on the up and up security-wise, I'd recommend using the installer and using the bender, so you don't have to use any elevated privileges to get the SAM executable installed. I think on Linux now, .local bin should be in your path automatically, at least on the latest versions of Ubuntu. So that should get you started. Beyond that, you won't need to really use SAM much from the command line other than verifying you've got the correct version of SAM installed, which I do, 1.20. we will stop looking at SAM at that point, because now we're going to go over into PyCharm. Got a little too much open here. Once I have pulled down the GitHub version of the code for this tutorial. It's tricky to find because it's buried in like third page of the tutorial. So don't fret, keep clicking. You'll find eventually a link that says to go to GitHub and get this version of the code. I did on a clean computer, just to make sure I could do all this, code this by hand, listening to Paul's soothing voice narrating while following along with the text of the tutorial. It does work. I did it without actually having to consult the source, but I did download the GitHub source to make sure it worked as well. I like to kind of validate, that this tutorial is actually really well built, and it is. It's really well done. So if you follow along through the tutorial, it'll guide you through the Hello World SAM project layout as it first starts it up. But if you just go grab the GitHub, you'll kind of get the already pre-made, pre-built out version of the tutorial. You'll have to configure SAM, like I mentioned. So if you open up your settings and you look for the AWS tools, you'll have the SAM executable. It should find it if it's in your path. So mine did auto detect it. If it didn't, you'll get an error when you try and actually create a new project using the AWS Toolkit, because there's an option for basically creating a templated project there. If it can't find SAM, that's where you go. Just go to the AWS tools and set that up. From there, you'll be able to now do some really cool stuff. For running the project, let's just run through quickly what it does. It is a simple project that is going to save users into a MongoDB database in the Atlas cloud. It allows you to create users, read users, update users, delete users, so your standard CRUD application bits, but it adds in a few more things that are kind of nice. For example, the ability to authorize into your API. So being able to get a username and password to grab a token, and then from there on out, all your API access can actually happen over tokens, which is a really good pattern for doing microservices. It makes it easy to deploy this application and protect it behind some kind of authentication mechanisms. One thing you'll note when you do try and run these, it's really, really handy. I'm a big fan of the run configurations inside of PyCharm. So I've got run configurations set up here, and then you're going to ask, how did I set those up? How did I get those things in there? And I will show you if I open up the template YAML file. So the project itself is, when you start up a serverless AWS project using the SAM template, you get a nice CloudFormation template, kind of hello world, already built out for you. And you just have to add a few extra little bits to it to start going with the tutorial. And so this defines all the resources that your CloudFormation is going to build for you up in the cloud. What's nice about the tutorial is it guides you through building all these things and getting it all ready without ever interacting with the cloud, other than Atlas for a database. You don't touch Amazon really until about the very end, when you actually launch this whole completed application that you have built and tested locally on your local machine into the cloud using CloudFormation. So the CloudFormation bits work locally to allow you to do things. You'll see that PyCharm has put these little plus or play signs next to the resources that I'm going to create. So in this case, I've got a AWS serverless function. That's just a Lambda. If I want to run that serverless function, I can click the play. And that's the quick way to get these run configurations created in my book. But you're going to need to make sure you select modify run configuration when you do. So if you open that up, this one's already been created. But the one thing you'll get if you didn't have this one already created is that you want to click on SAM CLI and check the checkbox for build function inside of a container. If you don't do that, it's going to try and run this in a remote Lambda someplace, and you've not got all the rest of the things kind of ready to go. So without that one function checked, it's going to try and do remote things instead of trying to do local things, and you want it to do the local things inside your Docker containers. And that's kind of the power of having SAM available to you. The other bit you're going to have to make sure you specify when you do modify this run configuration is going to be putting in this text for the input. So each of the tests, each of the run configurations typically takes some kind of input for the context to run that function in. In our case, most all of them take a body of some kind. There's a couple exceptions to that. But it takes a body, which the value for that key is going to be a string, which makes it look a little ugly here. But luckily, you get some syntax highlighting, kind of helps you type it all out. But that's why there's all these backslashes escaping the double quotes throughout this, is because it's not actually taking another dictionary or mapping as the argument. It's actually our value. It's taking an actual string and passing that in to the Lambda when it runs.
Kind of
So-
simulating HTTP data, right?
Exactly, yeah, because you may think you're simulating Python dictionaries, but you're not. It's really HTTP data being passed in, and that's all just strings. There's no data types there yet. So that's why you've got to kind of pay attention when you set this up. Again, make sure you got build function inside of a container. Make sure you got a body text. Those are the only two things you need to change to now have a run configuration available for create. So actually, the first one you will build is going to be create. It'll run you through the whole process of building the CRUD applications. If you do pull this code down from GitHub, you're going to need to modify the db.py. Each of these, create, delete, update, etc., all the CRUD applications have their own little folders in the project layout. If I collapse all this, it might actually make it a little easier to see what's going on here. If I look in organizations, which is kind of the root of my serverless application, you see I've got user. Now I've got here, create, delete, login, read, update, and authorizer. You're going to start creating each of those apps are their own little self-contained application, which is kind of critical to understand because you really can't pull in your code from other folders nearby. When Lambda goes to run these parts of your application, it's bundling each of these bits up into its own, app.py with the Lambda handler, and that only really looks for code that is sitting in the same level as the app.py file. So you'll see that I've got a relative import here for .utils to get my validator, my DB, and that's because I don't have access to anything below. So I can't share, unfortunately, and I didn't see a good pattern for this yet. I could not share the same DB settings file between all of the various applications in my Lambda app. But don't fret, it's not a huge deal. Each of these DB files is super small. All it is basically setting up a context manager for a MongoDB connection. And you'll see in the demo, it has in there, well, you can see right here, there's going to be, it's expecting a string of stuff, which is like the MongoDB connection string. If you go over to your MongoDB Atlas, so I'm logged in over here and I've got my cluster set up per the instructions. If you click on connect, you're going to want to connect to your application and it'll give you what that string is. Now in our case, we're not using my first database. We're using MyDB in the example. You'll see that in the code in here. So you'll have to modify this slightly when you go to paste it into your version of that code. But that's the connection string we're looking for here. And so the Cloud Atlas stuff guide you through all that. For the sake of this demo, I put my secrets in a separate file. And I also made it so that if I hovered over it, you wouldn't see my username and password. So I still try to keep it a little bit on the up and up, but you would technically want to use like either parameter store or secrets, a key manager, whatever the secrets password manager is inside of AWS to store those kinds of secrets and pass them into your environment would be the way to go. But I kind of did the next best thing, which was I made a nice, beautiful F string, which passes in my user, password, host, and a DB so that I can easily change those up if I needed to for other things. But if you do try and run this code without doing that, you'll be using Mukul's version of that connection string, which doesn't exist anymore. And I don't think you could access it anyway because you should have had it blocked off by IP address. Which is another thing to talk about next, was before you can run this, you still need to be able to talk to your application in the cloud. And so you're going to have to configure your network access under Atlas. And so I have my home IP currently put in there. Later on, when we deploy this, we will have to open this up a little further. And I'll show that when we actually go and deploy this into the AWS cloud proper. So
hey, can I ask you a question about that DB file, sharing,
absolutely.
not sharing, or duplication, I guess?
Yeah.
What do you think about doing, having it in a little separate section here as the source, and then doing like a pre-run task in all of your run configurations to like copy it over?
I mean, any kind of automation is obviously a bonus. I was trying to figure out a way that if I could create like a common library that I could either
like
bring
package.
in, like maybe a util package that I would use in all of my serverless applications like this that could go and grab it out of parameter store. The SSM parameter store in AWS is a cheap and easy way to store secrets like that.
That's what Mukul is talking about in chat, that he follows the principle of least privilege. If working with environment variables, try AWS SSM or Secrets Manager.
Yep. Yeah, the SSM will be considerably cheaper than Secrets Manager, so I recommend you check out SSM. There's like a per secret charge in Secrets Manager, where SSM It's way cheaper. Let's just say that. Maybe they have different use cases. I think the Secrets Manager has HSM, like hardware security stuff built into it. If you need that and you know you need that, then you're going to pay for it. But if you just need encrypted passwords stored securely, SSM's the way to go for sure. Yeah, so I'd probably have some kind of utility I would build inside of this application. I understand that was out of scope for what this tutorial does, so this was probably the best way you could go about that. In addition, in the utils, he put the validator in here. So this helps to encrypt the password. So we actually are encrypting passwords that are stored inside the database. Oh, once you do have your database configured, you can use DataGrip. I do have this configured over here to show, pull that up a little more. There's my DB that I've connected to. Here are the registrations that are in there. If I open that up, you can see that the passwords are encrypted in the MongoDB database. Well, if I could scroll over to it. There you go. So it's using that Argon 2 library to encrypt the passwords very securely. So there's no sensitive data other than, well, personally identifying information is in there, but there is no passwords in the clear in the database, which is definitely good practice. I'm glad he included some good best practice things like that. I mean, you could have just done the simple tutorial and put a plain text password in there, but then people copy and paste these things, and then it kind of perpetuates not good practices when dealing with databases. But yeah, the MongoDB was, again, very easy to get added in here. I just used the same connection string that I got from the Atlas site, pasted it in here, and I was on my way to just using DataGrip for browsing my databases, which is nice when you're testing because you can then actually see the entries being added and removed and changed and verify that your code's doing what you thought it was going to do. And then you'll do your tests and you'll be able to see that even clearer. But it's nice to be able to see that just quickly being able to interact with a cloud database like that.
Actually, he chose it just to make Michael happy.
It does make me very happy. All my stuff runs on MongoDB, and I love it.
Yeah.
No, that's interesting. I'm not a big Mongo person. We use a lot of Postgres. So Postgres and its, the new JSON store stuff in Django really makes me happy because I can now do Mongo-like things and schemaless type things, and it's really quite easy to do. So let's jump back over to the cloud formation template, because this is where kind of the magic is defined. As you put in here properties about that function. And so this is how CloudFormation knows to take this, bundle it up, and put it in the right spots when it actually goes into the AWS environment. You'll see that for example, the create user, there's no authorizer on it right now, so anybody can create users. But if we get down here into the organization user read, we only want people who are authenticated to be able to do that. So you can see we've got a REST API ID, which actually refers to my API. Which was defined up here at the top. So there is a serverless API, which is a authorizer that basically invokes the JWT get the token, give me a username and password, get back a token functionality. And that's all defined up here in the authorizer. And now this is just using some of the, like there's some templated code from Amazon when you go to do like a blueprint of a generic serverless app. There's an option in there for getting a JWT application. He did modify it a little bit for this specific purpose, but it is a pretty straightforward, easy way of seeing how to apply policies and basically protect your API endpoints that are living in a serverless application itself. So the authorizer itself is another serverless application living up in the AWS Lambda cloud, which is kind of nice. Okay. Oh, so then let me run this. Now that we've got our run configuration, I've shown off some of the code. I've shown our connection to Atlas. So we can now just click the little play button to actually run our create code. So that you're actually going to invoke the SAM command line to build our container and run that Docker image locally. So we're not actually building and pushing anything into AWS yet. We are strictly running locally against our AWS, our container that is running in Docker. So this one actually gave me a nice little validation message, which is this email is already taken. So I can go back in and modify that text that I'm passing into this Lambda so that I can actually get another user in there. Before I do want to say how nice it is to be able to do local dev against AWS Lambda operations. When I first started doing AWS serverless stuff, you kind of had to just fake it, make it work, and then push it up there and hope for the best. Here, you really get a true representation of what's going to happen, like even down to the duration and how much memory it used and all those kinds of things. Those are all configured in the CloudFormation template as well. But you get the real feel that I can run this over and over again locally before I kind of risk throwing this up in the cloud. And actually, I can write tests and do all kinds of the right things for building my code out. Let me make a new user so it actually works. So we'll change the email address. Oops, did I not edit configuration? There we go. So we're on the user create. I will change the email address over here to J2 and click OK. And now when I run this should be successful. It will, again, build the container, fires it up inside a Docker, runs it just like if it was running inside a Lambda for us. And we can see the output because now it's talking to Atlas, and now I get registered successfully. So that did work. If we click on our database tab, oh, I guess that registration is already open. We can now see JDO2, the big fonts. I don't have much screen real estate. There we go. So that user got created and put up into the cloud, nice and straightforward with the encrypted password. For other operations, so for example, if I want to test, like getting back all the users, there is a read operation. So I can get all the users. So if I run that one, that goes into the read module down here. And there are 2 bits to the read module, which are worth talking about. Is you can read and get all the users. So you can see there, I just passed back all the IDs and names and emails for all the users that are in my database. Or I can get user information for a specific ID. So if I pass in, if you look at the Lambda executor here, oops, there's a second one. Yeah, I'm missing it. Which is going to look for, for object ID. So if I pass in a specific ID, which I did have a second run configuration for that, if we read by ID, let me edit it so you can see it first, because I think it's important. In this case, we're not using body. We are passing in path parameters. In this case, this is going to be interpreted and used by the Lambda to pass ID and then a specific user ID to the Atlas query. So you can see here, it's going to look for the object ID and find a single object, and then it'll actually pull back just one user. So if we run this, and I know one of the big draws why a lot of folks are here, they want to see, how do I debug my Lambda code? How do I know if this is doing the things I expect it to do? Well, let's do that. Let's actually set a breakpoint and debug. Again, one of my favorite features, another one of my favorite features of PyCharm is very easy to debug code. When I was first starting out doing Python, back in the old days, we all just had PDB. When I discovered PDB, I was so ecstatic. Like, oh my God, I can stop my code and actually inspect things. And this is a whole nother level. So that worked. We got back Bob from that specific user. But if we actually wanted to see that happening, we wanted to double check, if there was an error, or we weren't getting Bob back, or we didn't know what the single object was, we can run this same run configuration, but using the debug mode. So if we click the little bug up in the run configuration bar, instead of clicking the play button, same thing will happen. It's going to build the container, but when it goes to run that container, you'll see it'll start up in the PyDev or PyDebug mode of PyCharm. There we go. So you can see it's going to connect it to the dev debugger, and boom, I'm in a container inside of SAM. I didn't manage any of this part. This is all Amazon SAM framework, kind of interacting with the AWS Toolkit, interacting with PyCharm, and PyCharm really does support talking to containers. It's just seamless. I can now see that where my breakpoint stopped me at, where all the objects are, what the object ID was, what connection strings. I can step through the code. So right now you can see here, I do have an object ID and I do have a single object that is being passed back. I can step over that, go to the next bit, and start actually stepping through all this code. And you get all the niceness that PyCharm gives you for doing debugging with your local Python code. It's still technically local, but it's running inside of a container. It's not something you can it's kind of opaque to probably new people who are trying to interact with the debugger, this works really well for being able to explore your code, understand what's going on behind the scenes. So I don't know, Paul, you want to take a quick break for our next intermission segment?
Sure. Let's go on to the intermission. We'll go over a couple of things that were brought up. They're not necessarily questions, but places for you to kind of inform the audience about the AWS ecosystem. First one is about single sign-on. Michael, I'll go with you first. Your Talk Python stuff is a big pyramid application. Are you doing single sign-on?
I'm not doing single sign-on. I guess, let me put it in context around like social sign-on. So can I sign in with Facebook? Can I sign in with Google? And so on. I don't know. I have mixed feelings about that. On one hand, sometimes I feel like it's, oh, this is great, I can just use this. But then do I really want to share my information over with that app? You know, how much are they asking for? And so I haven't added it, partly because I don't love the feature. But also, you know, it is more work and a little more tricky. So
Calvin, have you done any single sign-on, and if so, with any AWS machinery?
Not with the AWS machinery. I know, AWS has Cognito and their directory type services. We inside of 6 Feet Up actually use Keycloak for our single sign-on. So when we for our internal services that we do, Keycloak is a single sign-on identity manager from Red Hat. It's open source. We actually know some friends of ours who work on it. Christian Himes is one of the core developers. Yeah, one of the core developers. You know that guy. One of the core developers on there, and so it's a cool project. We use it with Nginx and Vouch to replace basic auth for getting the services that don't have natural like authentication screens associated to them. So you can now convert anything that you were protecting behind basic auth and give it a true login screen. And if they're already logged in to your authentication or identity manager, they just automatically get passed right through to whatever resources using it's called Vouch. The name changed somewhere along in there, but there's a sub request service we use called Vouch with Keycloak that basically checks if you're authenticated. If you're not, goes and gets your token, and then that middleware piece kind of manages the authentication piece for an Nginx, like just out of the box, which is kind of nice. Well, it's not out of the box.
The second thing is kind of related to this whole serverless paradigm. Cores. Cross-origin requests, security. I suspect both of you have become quite familiar with this. We'll say, Michael, you're the professional explainer. You explain the nature of the problem, and Calvin, talk about how with your AWS stuff you might tackle it.
I'll give it my best shot. So I think the thing that Cores tries to protect is, let's suppose I went to Stack Overflow and Stack Overflow had a script injection type of thing. I could put some JavaScript in my message instead of being, I have a question, here's my Python code, how does it work? It's, bracket script, try to access, I don't know, Bank of America. And then that person, if they're logged in another tab to Bank of America, would possibly forward that session and stuff like that. You can see drawbacks of this. So Cores basically says, you're not allowed to make those cross-origin, cross-site requests unless your site that you're going to, which in this case would be Bank of America, says, I allow this use case from other origins and whatnot. That's Cores. And I've had to deal with that for different things as well on my site to allow, for example, people to consume my API for exposing certain things. And back on their site, I had to open up certain parts of the site for Cores.
Yeah, actually, same with us. For example, for the LoudSwarm application, which is the platform we're hosting the Python Web Conference on next week, March 22nd through the 26th. Get my little plug in there. We'll talk more about that later. But for the LoudSwarm application, it is composed of many small Amazon applications, like serverless applications, either running in Fargate. The front end comes out of S3, but the whole thing looks like it's hosted as one application through CloudFront, which is the CDN product from Amazon. But to do that, I have to make sure I configure the Cores permissions on the S3 buckets correctly, because the S3 buckets themselves have their own URLs. They will think they're being requested from some cross-origin and will block access to that if I'm coming from, say, loudswarm.com. So in your S3 metadata how you configure your S3 buckets, you can then configure a core's access policy that will allow specific cross domains to do that operation.
Yeah, that's the part that gets to be a little confusing, is if you're running an application server like Django, it's in charge of the headers. And so you just write your application or do middleware or something. But some of these other things where all you can do is configure it in Nginx or Lambda, S3 buckets, or whatever. You got to go learn that language and how to associate it with paths and things. Calvin, tiny question before we go to Michael's topic.
Okay.
Get in, get out fast on it. Are you using Keycloak with free IPA as the directory DB or something like Active Directory LDAP?
We are using OpenLDAP. That's historic. We have had an LDAP repository for all of our internal corporate giant 6 feet up authentication needs. When we needed to now authenticate many kinds of applications, throwing Keycloak in front of it was just a natural choice.
When the end days arrive, it's going to be cockroaches and LDAP.
It'll never die.
Yes. Okay, let's go ahead and switch over to Michael, who's going to give us his AWS-ish topic.
Yeah, well, I thought, it'd be fun to just take a little break in the middle of this presentation and just highlight some other AWS services and features. Paul, you asked me in the beginning, like, what do I do with AWS? Am I a big fan? I don't run my servers on AWS, but I do find there's a bunch of cool little services, almost too many. You go to the AWS console and it's got that little section that says recently used, and there's like 2 or 3 in there. And then you can expand it. You're like, what is all this? Like, how did I miss 5 keynotes? And like, what else is going on?
During this webinar, there will be 2 more services.
Exactly. The scroll bar just got longer. We didn't know it.
You think you're kidding.
Yeah. So I wanted to highlight 2 things that I think would be really interesting that we leverage over at Talk Python Training that probably don't immediately come to mind for people. So for those of you who don't know, we have online video courses for Python developers, and we have all sorts of things that we have to do. And one of the things we have to do is we have to take really large, sometimes ginormous MP4 video files, and we need to turn them into things that are both in a format that is compatible with things like certain Android devices, with iOS, with smaller formats that you can stream and whatnot. So we need to generate multiple encodings that are predetermined to work with all the various devices. It turns out to be a bit of a challenge, but it works. And so what we do over there is we use AWS Elastic Transcoder, which lets you point at something in S3 and say, here's a MP4 file, make it whatever you want. It could turn it into an MP3. It could turn it into an MP4 that's re-encoded. So for example, we record at 1440p, but we also offer 720p options. And then we even have like little thumbnails. Like if you do a little scrubber, we just have a very small video that's the same video with no sound that like puts a little video player and like just seeks in the video as you scrub on the scrubber to show you. Like,
great.
Yeah. So we generate all those out of this little script here. This is one of the 2 sort of fun AWS things I could show you. So we have, I took these, I'm not sure if these IDs of the presets are important or can be messed with. So I took them out, but there's these codes over here on the right. And then we get our secrets secretly. And we have these different presets. Like, do you want 720p? And this really, this one really should be called 1440, but whatever. So what we do is we go through and we just have a directory of files of MP4s and say, hey, take those, upload them to S3, run a bunch of different codecs, get the 1440p version, get the 720p version, and so on, and then download those and reorganize them in the way we can then automatically drop them back onto S3 to like go out to like a global distribution. So here's just a quick overview of how you might use Elastic Transcoder. There's like obviously some stuff just asking questions and whatnot, but I'll just go down to the interesting bits here. So say I want to run this for a whole course. So we're just going to like loop over for all of them and get all the files and then run that against each folder. Each folder, we're getting there. We're going to come through and say, I'm going to create an S3 resource, because what you got to start with is put the videos somewhere that the Elastic Transcoder can get to. So we get that. And then we're going to get the Elastic Transcoder option. And then we're going to go and upload the files. For each preset, here's an interesting thing that you can do to like amplify your speed. So these take, however long it takes to upload. They might be 500 megs for a video, and it takes, 5 minutes or 2 minutes. I mean, if I was Calvin, I probably would blink, it'd be done. But I have gigabit but slow upload speeds. It's so not fair. Anyway, one thing you can do that's really neat to speed up a lot of these sort of asynchronous job stuffs in AWS is what I first wrote it was upload it, transcode the 1440p and wait for it to finish. Then transcode the next encoding and wait for it to finish. Then transcode the next one and wait for it to finish. But instead, what we're doing nowadays is starting the transcoding, and what you get back is this like waiter type thing you can wait on. So we start all of the jobs just all at once on AWS because they scale. So let them at it. And then we go through and we go down here with this complete thing. So you get this waiter and you just wait. So I'm going to create a waiter over on AWS and say, I'm going to wait for that one to be finished. And it might finish slower than some of the other ones, but it doesn't matter. You're just going to, they'll sort of finish behind the scenes, and then you just get them all at once really quickly. So it doesn't really matter what order they finish in. You just can wait for them in order. But the key thing here is to like start them off. So in order to transcode a video, once you've uploaded it, you just figure out what the name is. We use a bunch of random names all over the place because if the thing already exists in S3 where it's trying to generate the output, it'll fail. So we just randomly name it. So like in case we rerun it with a different output of the video, it doesn't crash. And then this is it. You go to that Elastic Transcoder client. And you say, create a job given one of these encoding pipelines with input settings, which are things like what is the S3 bucket, and the output settings, like what do you want to call it? What do you want to encode it to? And you wait. And if you do that, you can just do all sorts of automation with S3. Or with the last
2 questions from the audience. First, is this hands-free? You just put it in the bucket and it notices something was put there?
No, because it originates on my computer, and part of the getting it in the bucket is mine. So what I do is I just have a CLI. I just open up the terminal, a folder, which is like a huge batch of organized MP4s, and say transcode, enter, and then I come back in an hour and like I have all the videos re-encoded.
If you do want the automated, we do this as well. We don't use the Elastic Transcoder. We actually use the AWS Elemental Media Convert services.
Yeah, I think that's newer. That's a newer thing since.
So we have
very nice.
Yeah, we have a whole pipeline set up. It actually is all serverless, uses Lambda, and does those same things, except it just watches for stuff in a source bucket. And when stuff shows up in the source bucket, it just enables the pipeline, throws those things through it. We end up with an HLS file on the other side, plus thumbnails and all this, the exact same thing you're talking about, Michael.
Yeah, that's awesome.
Right, one more question, then we'll get out of this. Either one of you can handle it.
Whole new session.
Why do large files make the process harder? Computing limitations, cost? What is it?
Well, the goal is I need to have it so that people can, I'm sure Calvin has the same thing with Loudswarm, is you can't give somebody a 500 megabyte file for a 1 minute video, right? That's problem one. Like a lot of people just don't have that bandwidth. You also run into weird issues, like people say like Chrome is crashing because this browser used too much memory because it preloaded like a huge video. You're like, why would it do that? Like, this makes no sense to me. But that's like, you run into all these problems. iOS will only play at like a certain bit rate. If it gets too high, it'll freak out and just like not play. It'll say the format's not supported. There's all sorts of weirdness. You like got to get it down in the encoding. I don't know, Calvin.
And there's complexity involved there. Like if you have an older laptop, those CPUs can't do the higher complexity encodings. So we actually encode into one bundle, one package, like a low bitrate, low complexity one, so that they for sure can watch it no matter where they're at on whatever device they're on. So there's a ton of like, I mean, if you look at the Apple encoding recommendations for like HLS, they want you to put like 10 or 16 different types of the stream in one like bundle. We don't do that many, but I think what we've chosen is a good mix of accessible to old devices, slow connections, and playable by modern, fast connections, nice devices. Yeah.
Calvin, would you say that you don't want to do it by hand though?
Oh my gosh, no. No. It is a complicated beast. Luckily there's a reference. The one we use is based on a reference implementation from the Elemental docs. So it has a whole, just like we showed in the the tutorial we're going over right now, it has a CloudFormation template that you basically upload, but it's got some stuff you can, like a lot of variables in it. So the one thing we're not showing here in CloudFormation templates is you can actually provide a bunch of variables and placeholders, so you can actually customize applications and launch them multiple times with CloudFormation. And so this has a bunch of like options, like, do you want support for X, Y, and Z? And then you just answer yes and no. And then it basically will build a new pipeline with all the right Lambda pieces in it, all the right loggers in it, all the right stuff. And ours even pushes it into a target S3 bucket and sets up a CloudFront a CDN, so we can basically republish those videos as soon as they're encoded.
All right, we'll go ahead and get out of this one. Mukul pointed out that you could also use AWS step functions to automate the workflow.
I do use step functions in ours.
There you go. All right. And I'll just make a personal comment. The two of you are no longer software engineers. You're like microphone engineer, camera engineer, and video transcoder engineer.
Yes, exactly.
All right. Okay, let's go ahead and switch back to Calvin's screen. Calvin, do segment 2. Go ahead and pack everything you can into segment 2. We're over on time.
Okay, will do.
So just go to the end on what you want to show.
Okay, I'm going to jump over here and show in the tutorial. We've gone through everything into setting the MongoDB database to writing our REST APIs. The last bit I wanted to show was the server, like securing this API with a JSON Web Tokens, which is not as interesting locally, because locally it's just going to kind of accept everything you throw at it. Although it does work. Let me show that off in the demo. So if I close up this, if we look at the auth login, here we go. So in the login handler, this is going to look for a username and password, or email and password. And if it's good, you get a welcome message. If it's bad, you get an error, or else you get like a 400 saying something went wrong. So there's a little bit of error handling in here. And then it also has ability. So the way JWT works is typically when you log into an application through the web, you'll have a login screen. This is actually how LoudSwarm works as well. You have a login screen that goes to an API endpoint like this for login. That login just gives you back a token. And from there on out, you use that token, just like you'd use a cookie necessarily, to talk to your application. But since we're not talking to web pages and standard, old school server-side generated like applications, we're really talking to API endpoints. So API endpoints, it's much more native to use some kind of a token either in a header or an authorization in a header, or you can pass it in some number of ways to get that token back to your app. And you have to periodically refresh your token so that you want to roll these tokens on the server side so that people can't stay in the login forever, or people can't steal tokens from other people's computers and then log in maliciously as your app. So this actual example does support showing off refreshing the token. So I'm going to go ahead and show the user login. And so the user login, if we play that one, again, runs locally on our Docker container. I've not gone anywhere in the cloud yet, which is still kind of mind-blowing. We're talking about AWS, but I've not gone anywhere in AWS, but I am using all the AWS tools locally. Okay, so it runs this guy, does the login, passing in an email address and a password. And so I get back the welcome message with our token. So if I grab that token out of here, copy that, and now I want to refresh my token. So if I wanted to, typically when you refresh your token, you pass in the old token and then go get a new token that will expire some later point in the future. I'm going to change this up by putting in, maybe. I have VI key bindings to the rescue here. All right, and I'm missing, there we go. That should, yeah, perfect. So I put in my new token into that run configs like text that it's going to send over as part of the body. When I click run, this should pass me back a correct new token. And the next thing I'll get to is we're going to show pushing this into the cloud, because that's where the real interesting, fun parts happen. Because we've really gone over the whole code. There we go. We now have a new token ready for us to use for accessing our API calls. So let's get this in the cloud. Enough talking about it. We do have the AWS Explorer, or AWS Toolkit installed. It does give us some new functionality in our UI here. So we have the AWS Explorer. Let me collapse this. Get rid of this too, because we don't need to see the project anymore. With the AWS Explorer open, I can use multiple profiles. So if you follow the documentation for the Amazon CLI, it'll ask you to set up credentials and profiles for your CLI. And those are the same thing you get used here. So you can see I've got a default profile. I've got a serverless demo profile. There's also a C-Parker profile in there. So I'm going to be using the serverless demo profile. You may ask, where does this come from? If I open that up, because it's actually interesting to understand how this works. I've got in the .aws folder, which is where they tell you to put these things, there's going to be a config file and a credentials file. So you can split your credentials out of the config, and in config you'll have things like what region am I typically acting on? Is there an assume role going on here? Those kinds of things. But credentials is just going to typically be your key, your secrets and your keys. So if I look at my credentials, and this drove me nuts. I hate having credentials on a file system. That I had to go a little bit extra here is that the AWS CLI and the AWS Toolkit inside of PyCharm both support this credential process argument to it. So you can see here's my serverless demo profile. Instead of putting in AWS secret key and AWS access key as properties here, I put in credential process, and this gives me back a JSON by running some command. Expects a piece of JSON back from running this command. So I use KeyPass XC because it has a CLI that I can run from the command line. It also has a GUI that I can run like this. So I'm running, here it is, there's my serverless demo. If I opened it up, you'd see my keys and stuff that are in there, but I didn't want to show that off because I wanted to keep my credentials encrypted everywhere. So through using that, I can now do things like this. I can say dash profile. If I want to see the contents of the S3 bucket, I can do S3. Oh, sorry. I need to specify the profile, which is serverless demo. S3 LS. Nope, not S2. S3. So that in real time runs that credential process, grabs my credentials out of the encrypted store, and then goes and does the S3 call using that in my environment. So nowhere in my environment do I have the AWS like credentials even in my environment variables, which is kind of handy. Really keeps that credential secret mess out of my way. So same thing works here. The toolkit supports looking up and using that credential access process. It doesn't support all of the things you can put into that credentials file in the AWS folder, but does support that one, which is important because now I can select it from my list of credentials. I can select what region I want to run this in. And then it opens up, gives me a few nice options here. So I can actually browse the lambdas that are created. So these are the serverless demo lambdas that will be uploaded. I can see the CloudFormation stacks that are up there. So I did run this earlier. We can run this again. Let me actually change something so it does build. So I just made a quick little change to the text of that body in the login app. And if I go back to my project, and you can just right click on your project, you can go down here to deploy serverless application. If you hadn't already deployed this, you would say create a stack. So you put in the name of the stack you're going to create. Since I've already created a stack, I'm going to just update the existing stack with new code. So it basically does a new revision up there. And you can actually go back and forth in history in the revision of your stacks. You don't need to worry about any template parameters. You do need to select an S3 bucket because what it does is it actually uploads the template, the CloudFormation templates into an S3 bucket, and then it points the CloudFormation API at that bucket and that CloudFormation template to actually then go build all your cloud resources. So you create a new bucket. I just made a Calvin HP serverless PyCharm demo. You have to make sure it's unique globally. That's why I put the Calvin HP in front of that. The tutorial tells you just to use serverless PyCharm demo. You'll get an error because that probably already exists someplace. And then you can say require confirmation before deploying and build the function inside of a container. Again, make sure both of those are checked. They're not checked by default. If you check both of those and then click deploy, you'll now get the build, just like before, it's building the container. And then the next thing that happens is different. Is going to be it pushing it into CloudFormation instead of just running it locally. So it's copying all the bits, putting it up into the S3 bucket. So you can see here it's going to my Calvin HP serverless PyCharm S3 bucket. It will be like, okay, cool, you do have changes, code has changed. We're going to just waiting for the change set to be created. It will next ask me to confirm that I want to build all these CloudFormation objects inside of AWS, and I say I do. So I click continue deployment, and then new magic happens in your PyCharm UI, which is pretty cool. I had not seen this because I didn't get to the very end of the tutorial. Is it actually has built into it a CloudFormation, and I also found out CloudWatch logs has new little panels down here at the bottom, which actually show you the create in progress in real time. It actually, if it was building it from scratch, you'd see a lot more going on. But it tells you once these resources have created and been pushed up and ready to go, and then you get a nice success message when it actually all is done. So that is really handy for seeing the status of all the creation of your objects. And what's interesting, it looks like we're only creating a few Python files here and there, but we're really creating a whole application suite of Lambdas that are kind of working together as one application inside of the UI. And if we go look at the actual AWS console, this again, another beautiful thing about this is I've not touched the AWS console at all. There's no point and clicky. There's no click salad for like configuring all these things and getting them to work. But if I come back in here, I'll just go to root of the Lambda so you can kind of see the whole experience. We've got a Lambda application in this case that we've deployed. So if I go to the application, you'll see here's my serverless demo stack, which is a composition of many Lambdas. It has an endpoint on the API gateway, so it's got nice easy access for that. And then here's all the things I listed in my CloudFormation template are all separate. So if we go to user create, it is a Lambda, but composed into one application here. You can inspect the code, so just like you would from a regular Lambda. If I was going to go to, oh, there it goes. Took a second for the code editor to pop in, but yes, you do see it did take my requirements.txt file. It did install all those bits into my Lambda for me and package it up as a zip file, and then push it into Lambda. If you want to see your code, you're going to want to look for, this is the create function. So the one that's actually running is inside of create. There's our app. If we open that up, it's just like the same, it's the code we had on our local machine, but it's actually been pushed into Lambda for us, ready to run. So we have our application has been deployed. It's sitting behind an API gateway. So if we click on the API gateway, you can see there are, oops, actually I should go over to the API gateway. I'm not a fan of the UI of the consoles. Any cloud console is overly complicated. So I highly recommend CloudFormation. Personally, we use a lot of Terraform for this. And Mukul mentioned that in the tutorial, is that CloudFormation is not the only way to do this. You could do this with Terraform, and I do find that to be a really nice solution. But look at this. If you had to click through and configure all these things by hand, you would be still clicking right now if you started at noon, I think, to get this all done. But CloudFormation wired it all up, made it all go. It's really nice. So you can see here, if we click on the login, it basically is a post. What's important is to look at the stages. We deployed into prod. That's configured in my CloudFormation template. This is the important part here, this endpoint. I'm going to copy that link. Let's actually try our app. We're going to use Postman. Let's go over here, and I'll replace out this part of the URL. Oops. There we go. Click send. Now you'll notice it didn't return right away. What's wrong? What is possibly going on? The next thing you're going to get hung up on is inside of MongoDB, you will need to allow access for anywhere to access this specific host. I'm going to configure it for just only 6 hours. This is not good practice. I don't recommend it. And there is a way around it. You can do peering and private encrypted endpoints with MongoDB Cloud Atlas, but you can't do it on the free tier. So the only option.
Callie, can you zoom in your browser a little bit so people can see that?
Yeah. So what I did was I added in an IP address here for everything, the whole world, to basically be able to access. Now they can access. They still have to have my username and password, but blocking it off is better than having it open to the world. You don't want to have this open to the world. I set it to automatically go away after 6 hours. The real option for this is basically peer your Atlas VPC with your applications VPC, and Lambda does support this, but you have to have a paid connection or paid Atlas account. You can see here dedicated to your M10 and above to be able to do this. So for this tutorial, the only option you have really is to do the access lists of everything to 00000. And you see here, endpoint termed Atlas. Now that I've opened that up and click login, we should get welcome, and we did. So you can see down here, here's our welcome, here's our token that is running in Amazon going through API gateway. So that's what this URL's endpoint is, basically hosted on the AWS API gateway that is pointing to our Lambda serverless microservice application running all in the background. You can take now this token inside of your Postman. Let's copy that. And if I go to get a list of the users where I need to be authenticated, you'll just go to headers. Well, actually, what I should do is make sure I put the right URL here. And we'll kind of end on this. So there we go. And we'll go down here, and you just have to add an authentication header, which will be the token I just got. Boom. And send. And we should get, you know what? I had trouble with this earlier, and the reason was I was not grabbing the raw version of the token. So I'd recommend, I think it had some carriage returns or something like that in there when I copied it. So I'll copy it for the raw version and go back up here and try this again. Paste. And now we'll send. Yep, that was the issue.
Good catch.
Yeah, so there we go. Now we've got a list of all the users who are in our system, and it's authenticated. It's all behind authentication. It's all behind HTTPS. It's all relatively good practice from a security hygiene, other than we had to open up our database to like everything. Another thing of note, in the tutorial, it will say you need to give your your IAM user, so the API user that you're using as a service account with Amazon, full access. Make sure you analyze this on a per application basis and give it only access that it needs. But for this, purposes of this tutorial, and I'll be tearing it down afterwards, it's probably okay to keep that in there for now.
All right, Michael, I'll ask you for some commentary. Before I do, Calvin, can you go back over to the Mukul's tutorial?
Oh, on the web? Yes.
Yep. And just to point out one part we didn't have time to talk about, scroll down near the end and test. Testing.
Testing. Here, let me run real quick.
Yep.
Is that what users do?
Sorry, go ahead.
Is that what users do?
Yeah, that's what the users do. No, it's what the code should do. So
this part was interesting.
Yeah.
So we do have tests, and which is nice. I think it's a great inclusion to any tutorial is to include testing. There we go, tests. So if you look at the unit tests directory, there is a test handler in here. Let me get rid of this stuff. And so it has a fixture for PyTest, which means you can you can randomize the data coming into your test and run it many times with different parameters. And so it does have a test lambda handler, and it does have a teardown. So it will go in and look for the last user ID that it created and delete it out of the test. They run really fast, which is another good reason to run tests, because if you do good ones, see, it runs very fast. And you've now have your code in a place where you can make modifications, enhancements with reckless abandon, knowing you've got tests to ensure you're doing the right thing.
And thanks for running that. At the top, you talked about how it's a little bit painful that all these functions are in isolation and imports are a bit of a pain. But this is kind of the payoff, is that they're all in isolation. So writing a test against it and running is pretty easy.
Pretty core.
Michael, got any comments on this testing part, or just in general, any of what you saw?
I like the tutorial. It was interesting. I learned a lot. I hadn't done as much as I could with the AWS Toolkit for PyCharm, so that was neat. And good overview, Calvin. A couple of thoughts, I guess.
Thank Mukul. This is really a lot of work here.
Yeah. Well done, Mukul. That was very nice. And I guess one thought here, I really like the way that it used like proper REST concepts around the endpoints and stuff, right? Instead of having a create user, list users, endpoints, it was /users, and then you do a put, you do a post, or you omit the URL, the ID, or you include the ID, and just like sort of a seamless URL interaction. I really appreciated the way that I thought that was nicely done.
It's interesting. He in his tutorial used Postman. And Calvin, you used Postman.
I know. I
didn't have time to get him to use our .http support.
I love the .http support. I bet we can even show it off real quick. Is there not a way to like copy the curl from Postman?
There is. There is.
Copy the curl.
Because if you can do that, where's
you
that
pull down either send or save. I'm not sure which, but there's somewhere you pull it down. Try that one. Now there's a way to generate the code from it.
If we had it real quick, I would totally do that, because I do. Oh, here's code.
Yeah, that's it. Right. It's in that area. I just in the wrong one. Yeah. There's there's a curl, there's a Python, there's all sorts of different languages. That's super cool.
This is
So while
totally-
Calvin's setting that up, I'll give an explanation. We have basically a REST client as .http files. So you create a file ending in .http, and then it's a little bit like code that looks like curl requests, but you can run them. And they've become kind of this entry point for us to, over the course of 2021, do some really crazy things like inspecting Swagger, open API endpoints, and auto completing your post. It's going to be pretty cool.
So here we go.
So,
I took the curl from Postman, converted it into an HTTP scratch file, and now I can just run it, and I get a run output. And you'll see I got a 200K with my token. So that was from inside PyCharm.
Well played. I felt bad for springing that on you, and you and Michael walked through it first time. Okay, on to the question. It's worth more of a statement. It's worth mentioning that we use containers for Lambda rather than a zip file. The image needs to be in ECR. I imagine if pushed from PyCharm, the image will be uploaded to ECR too. Does this mean anything to you?
No, that's not the case here.
Okay.
I do know what that's about. So we actually use ECR for our container registry for our containerized applications. In this case, it is just using the container for the build locally, and then pushing a zip file of the resulting code in the container up to Lambda.
Cool.
So it's not using ECR in this case. I don't know if there's an option for doing that. So that's one of the new features they announced at reInvent last year, was the support for actual Docker containers inside of Lambda. So you can actually push a small actual image into ECR and actually have your Lambdas run that instead of running a zip file of code or something you typed into the browser as like, Python or Node or whatever you were running your Lambdas as. I'm super excited about that because it really validates that like the Docker container image, the container standard is truly a good standard, and that Amazon's behind it. And you can now basically wrap up any kind of application you want into a container, and it just runs your entry point.
Okay, next thing is, last time I checked, Docker Hub or other repos were not supported.
I don't know if there is there repo support, like container repository support inside of here? I don't think there is.
Okay. Last one is, before we go into the last intermission, about the IAM permissions. Did you mean that allowing a user access to only the services that are used in these tutorials?
Yeah. So what's happening with IAM is on the other side of this, where my API user is inside of the owner of these objects is the API user that I created for the tutorial. If I go into IAM, and so pro tip to anybody, if you can master IAM, you are going to be really good on the job market, because there's a lot of people who don't master IAM properly and should. So what I've got is my SAM demo user. This is a API only user. It doesn't have console access. So there's going to be credentials associated to it down here, but it's associated to now groups. And I had to add it into the admin group. I had given it originally full access, S3 full access, API gateway administrator, and some other things. Mukul mentions this in the tutorial that AWS Lambda full access has been deprecated. And so to basically kind of make this tutorial work quick and easy without having to go into a lot of detail, you kind of did the equivalent of the change mod 777 and gave it full administrator access, and away you go. So not a good practice. I will be deleting all these objects. Actually, another nice thing here is with deleting all these objects, if I wanted to get rid of this whole stack of stuff, I can just come in here, right click on here and say delete stack. And all of the things, it's obviously like, do you really want to do that? Yeah, let's see here. Serverless demo stack. Once I do that, it will open up and actually show in CloudFormation that it is deleting out all my junk that I just created. And now my application does not exist on the web anymore. All that permission should be gone.
Maybe Michael has to do a complete Talk Python training course on that one AWS screen.
Yeah, it could be.
It's a worthwhile venture. So there you go. You can see it deleting out all the objects now. So my API is now gone.
Yeah.
All right. Thanks for that. That was the last question that we had to answer. We'll switch over to topic 2.
Yes. I'll pull that up.
And then we'll head to the conclusion. So Calvin, this is your topic. Amazon FIS?
Yes, FIS. So Amazon during reInvent this year, actually during Werner's, the CTO's keynote, he introduced the fault injection simulator. You've probably heard of Chaos Monkey, made famous by Netflix. Actually, the master of disaster was Jesse Robbins in the early days of Amazon. But Netflix, took this to the next step and actually automated chaos inside of your infrastructure. The idea being, I can rail on enterprise apps all day long, but you need to be able to architect your applications to withstand failure. They need to be able to be running and have any piece, any part, anywhere, gone, degraded, low bandwidth options. And this is basically automates those kinds of tests. So you set up a fault injection simulator. I think they call it a challenge, maybe, or a lab. And right now it supports specific things like it can reboot instances or stop instances. It can drain load balancers. It can throttle traffic. So it can actually inject API throttle errors into the stream to make sure that your applications are resilient to all these various kinds of failures. So you go and it's called an experiment. So you go and create an experiment template. You tell it what you want to fail in your application, and you unleash this upon your infrastructure. Now, it does have the ability to filter out and say, I only want to run this on my test environment or things that are tagged with specific AWS tags, because you don't want to, obviously, if you're not comfortable with it yet, you don't want to unleash it on production, but you do want to do it in your dev test environments first, and you do want to do this in your production environments. Amazon and Netflix do run chaos experiments in production, because how else are you going to know it works? So that was announced generally available as of today.
I apologize. We were not showing your screen for that.
Oh,
but I think people can go find Amazon FIS on their own.
Yeah,
this concept does come up quite a bit in Python and automated testing and things. And Michael, you may have had something in the past about this.
Sort of. I did an interview with Roy Rappaport he's kind of in the monitoring overview of all the Netflix services running on AWS, and talked about chaos engineering. So it's way back when, but it's Talk Python episode 16.
Wow, that was a quick recall.
16.
Got them all indexed in there.
What number are you up to now?
I think 307.
Wow.
That's not including Python bytes either.
Yeah, thank you. Yeah, been going for a while.
Yeah, it's awesome. Yeah, there was a blog post this morning about FIS from Jeff Barr. So if you just go to the Amazon Web Services blog, you'll find it. And that's what I was referring to. But it's really cool.
Interesting they brought that in as an official feature to kill their other features.
Before we close this out,
go on one second. This is definitely a dig at the enterprise software people, like the VMwares of the world. This is our stuff will run. It'll keep running. Don't worry about it.
Yeah, I was going to ask that from a Python perspective. Do either of you feel like the Python community pays enough attention as it should to chaos, FIS, whatever?
I mean, it's company by company, right? It's what that company values. I mean, are they doing unit tests? Are they doing testing in their infrastructure? Are they doing load tests? This is just the next evolution, I think, from those two bits. Is okay, we can load test it and make sure it runs under load, but does it run under load while things are failing? You gotta know that if you're having
a good episode.
Yeah.
There's a lot of interesting stuff. Are you running in Kubernetes? Do you have database clusters, or you just have one database server? All those types of things. Yep. But I do feel like we're in a pretty good place as a community. I mean, how many times do you go and see a website this is going to be down Sunday because we're working on it? That I've seen that recently. I do stuff with Upwork, and I'm Upwork is down for maintenance on Sunday. What do you mean it's down?
Right.
What have you built that it's down for 6 hours? I just don't even. I can see down for 10 seconds, but 6 hours, I just don't get it. I feel like I don't see much of that, right?
Yeah, our human resources portal for our company was not our software, but our company's human resources portal was down for 4 days because they got a ransomware attack. I was like, what are you doing? Can I almost want to call them up and be like, can I help?
Yeah.
Hey, before we get out to conclusion, I hear the two of you are doing something next week at some conference.
Oh yeah, there is something going on next week. Actually, I wore the official shirt here. So
I didn't bring my jersey today. I had it last time.
I know. So Python Web Conference is next week. That is going to be the kind of premier global Python Web Conference. We've got 4 tracks. We've got a cloud track, Python Web App track, culture track, and an official PyData track. So if you're a data nerd, this is an official NumFocus, sanctioned PyData track. We've got 5 days of talks. There's going to be tutorials mixed in. They're only half days. We're trying not to burn people out with the crazy, what we used to realizes in-person conferences where you travel to a place and you went to a conference all day. People still got to work and people got to, families and things. So you can pop in, check it out. The recordings go up right away. So in about 10 minutes after any live session actually happened, you can actually check that out.
I think we now know how and why.
Yeah, we're using the Elemental Media Converter on the back end. Very solid. It is going to be hosted on Loudswarm, which is running on Python. So it's kind of Pythonception. Yep. It's Python all the way down. Tickets are like, $199 for professional, $99 for a student. And we do have a grant program. So if you can't afford to be there and we want you there, we want you not to miss out. So apply for the grant if you don't feel like you're capable of either of those ticket prices. We want to make sure you can experience the Python community at its finest. There is an amazing lineup of speakers. Michael's one, I'm one, Paul's one. We're all three going to be hanging out and doing some fun stuff as well over lunches. I think there's going to be a quiz bowl thing we're going to all be involved in, which should be a ton of fun. There's going to be some gathered socials. Hopefully this is a good substitute for missing out on things like PyCon and DjangoCon this last year. Being in person, we try to make it as interactive as we can. There is a 15% discount. I don't know the code. Do you know the code? Paul, you guys have got a code for a 15% discount.
Hey, Valeria, post the code in the chat.
She'll paste it. Great.
Michael, what are you talking about?
Well, let me give you a bit of a teaser. So yeah, I'm going to be talking about like a Python memory deep dive, like understanding how Python allocates memory, how it cleans up memory. And, that's theoretically interesting, but what are you going to do with that, right? But I'm also going to show some techniques and some code and some design patterns that will let you use way less memory, as well as just some settings you can change. As going through some of this, I realized there's some odd defaults for like data-driven web apps that might have to work with a lot of stuff. For example, I realized on the process of rendering the sitemap for TalkPython training, which has like 6,000, 5,000 pages, it's got to do a bunch of database queries. It ran the garbage collector 77 times on one request. I'm like, that's probably suboptimal because none of this is garbage till the page is done. So this is really weird, right? And there's a couple of settings you can just change, and now it runs it once or twice instead of 77 times. You can imagine your code runs faster if it's not like randomly just hashing the pounding the garbage collector for no reason. So anyway, like diving in and understanding like, I could change this little thing and it'll make a big difference. That's what I'm talking about. You?
Thank you for talking about that. It's like poignantly personally interesting to me for my side project right now, but also for everybody in the web community. It's super important. Even including back to this serverless stuff, you might be on a micro instance or something. Yeah. And Calvin, for all of you at 6 Feet Up, thank you for giving Python and web a home that can really focus on a lot of the topics in Python and web. So really appreciate it.
Yeah, I'm excited. It's going to be a lot of fun.
All right, let's go ahead and close out. Switch over to my screen. Thanks, Calvin, for giving us a review of this tutorial of AWS in general, AWS and Python and PyCharm in general. Michael, thank you for participating with some AWS commentary. I think that we could do a whole episode about how you run Talk Python. It's really interesting. If any of you have any questions later, please don't hesitate to reach out to the PyCharm team by email or social media. If you'd like to get more information on PyCharm, go to our website, jetbrains.com/PyCharm. Pretty easy. If you haven't already, check out our blog. You can get educational resources, upcoming news about news and events. Little pro tip, something's going to be announced in the next couple of weeks in the world of PyCharm. You can probably figure out what it is since we are in release candidate area. You also find information about the recording of this webinar. We'd love your feedback about this webinar, about this format. Contact us on Twitter or in the after webinar survey, which we will email a bit later. We read those things. We try and pay attention and learn and get better on all of this. That's all from us today. Thank you very much for our esteemed guests. Calvin, thank you.
Thank you very much for having me.
Michael, as always, thank you very much.
Thanks so much. Thanks for letting me tag along.
All right. And I'll be tagging along with both of you again next week. And thank you to our esteemed guests for joining us and staying to the end. Hope you have a nice day.